Hey Algebra 2 students, today we're going to talk about section 13.2, which is graphing angles and then different ways of expressing angles. So let's start off by getting a title on our paper. Okay, so when you graph an angle in standard position, you are going to start with your coordinate plane, your xy axis, and an angle is made up of two rays, and the vertex of the ray is going to, or the vertex of the angle is going to be the origin. And so one ray is going to start excuse me, on the x-axis, and that's what we call our initial side of our angle. And so depending on whether the angle that you're graphing is positive or negative, the angle can either rotate counterclockwise or rotate clockwise. So if you are graphing a positive angle, theta, and we'll just assume it's in degrees right now, you're going to be going counterclockwise. And if you are graphing a negative angle, theta, you are going to be going clockwise. Okay, so let's just say your angle opens up, and let's just say you're graphing maybe 90 degrees. Okay, so your ending ray would be the y-axis if you were graphing 90 degrees, and that's what we call our terminal side. Okay, so an angle has an initial side where it starts on the positive x-axis and then it opens up around that origin, rotating around the origin. And when it stops, we have a ray that we call the terminal side. So let's practice graphing a few angles. So let's look at the angle 240 degrees. So I'm going to draw my xy axis, and I'm going to put my initial ray on there. And then think about, each quadrant is 90 degrees, okay? So when we get to the negative x-axis, that's going to put us at 180. So we want to go 60 more degrees past 180. So this is our angle right there. And our terminal side would be located in quadrant 3. Okay, let's try 400 degrees. So I'm going to start off with my xy axis. I'm going to put my initial side on there. Now 400 is more than 360, so that means we're going to have to travel around the circle more than one full rotation. So how much more? Well, if you look at the difference between 400 and 360, it's going to be 40 more degrees past a full rotation. So when you graph angles that are going to be traveling around more than once, you are going to show that by doing a little spiral here, and then we're going to stop here at about 40 degrees there. So our terminal side is going to end up being in quadrant 1. Okay, and then let's look at graphing negative 130 degrees. So I have my initial side, which is on the positive x-axis, and since it's a negative angle, I'm going to be going clockwise, and I want to go, excuse me, 45 degrees past negative 90, so that's going to put me like right here, splitting quadrant 3 in half. Okay, so that would be my angle, and that would put my terminal side in quadrant 3. So coterminal angles are angles who share the same terminal side. Okay, so for instance, if we graph, we just graphed the angle 240. Okay, so that angle was in quadrant 3, so there's 240 there. So I could go, counterclockwise 240 degrees and it'd get me to this terminal side located in quadrant 3. But is there another way I could get to that same terminal side? Well, maybe I could go in the negative direction. How many degrees would I go in the negative direction if I wanted to get to that same terminal side? Well, I could just do some simple math. 240 degrees take away 360 degrees, and that's going to put me at negative 120 degrees. So we would say that negative 120 degrees and 240 degrees are coterminal angles because they share this same terminal side. You can also have positive coterminal angles. So if we were going to graph a positive coterminal angle, going in the positive direction, landing at the same terminal side, but traveling a different amount of degrees than 240, well, I would have to go around the circle more than one time. So let's see here. If I traveled a full rotation, 360, and then an additional 240, that would put me at that same terminal side right there. So let's see, 240 plus 360 degrees, that's going to put me at 600 degrees. So 600 degrees and 240 degrees are what we call coterminal angles. So all of these angles, 240, 600, and negative 120, land you at the same terminal side. Let's try finding one positive and one negative coterminal angle to the angle negative 65 degrees. So let's first graph negative 65. Excuse me. So negative 65 is going to put us in quadrant 4 here because we are opening up in the negative direction, which is clockwise. Instead of going clockwise, is there another way? Maybe we could go counterclockwise, which would be the positive direction. How many degrees would we need to go counterclockwise to get to that same terminal side? So maybe we'll do, let's see, what is the difference between 365 degrees? So 360 minus 65 degrees. How much is that? So 360 minus 65, that's going to give us 290 degrees. Or 295, excuse me. 295 degrees. So if I went 295 degrees in the positive direction, so counterclockwise, that would put me at the same terminal side as negative 65 degrees. If I wanted a negative coterminal angle, maybe I can go more than one rotation clockwise. So let's see, 360 and then an additional 65 degrees below that x-axis in the clockwise direction. So let's see here, if we did negative 65 degrees minus 360 degrees, and that's going to give us a total of negative 425 degrees. So we have one positive and one negative coterminal angle for negative 65 degrees. So I want you to practice one now. I want you to graph the angle 150 degrees in what we call standard position, so on the XY axis, and I want you to find one positive and one negative coterminal angle. So go ahead and pause the video And when you're done and you're ready to go over the answer, you can press play and resume playing, and we'll go over the problem. Okay, so let's check your work here. So when I graph 150 degrees, that's going to put my terminal side here in quadrant 2. Okay, so then if I want to find one positive and one negative coterminal angle, what I'm going to do is I'm going to take 150 degrees and I'm going to add 360. So I'd have to go around the circle more than one time in the counterclockwise direction if I wanted a positive coterminal angle, and that's going to put me at 510 degrees. That's the green one there. So that's my positive coterminal angle. And then if I wanted to find a negative coterminal angle, I want to go in the negative direction. I want to take 150 degrees and subtract 360 degrees, and that's going to put me at negative 210 degrees for my coterminal angle. Okay, so now we are going to talk about radian measures. So a radian measure is a way to express an angle in terms of the length of an arc that's intercepted by a given angle theta in relation to the radius of the circle. Okay, so if we have a circle with radius r and we have angle theta, let's say for instance that this arc length right here, call it S, is the same length as the radius. So actually I'm going to change that to R. So the arc length R is the same as the radius. We would say then that the angle theta is equal to 1 radian because the arc length is the same as the radius. Similarly, let's say we have a slightly bigger angle, maybe twice as big, so then the arc length maybe is twice as big here. So then say for instance I'm able to fit 2 radii along the arc that's intercepted by that angle theta. That would mean that I have an angle that measures 2 radians. Okay, so a radian, it's a different way to express an angle measure, and we are looking at specifically the arc length in relation to the radius of the circle. We have a couple conversions. If you wanted to take your angle measure in degrees and convert it to radians, we can use the formula theta degrees times pi divided by 180 degrees. So that would convert an angle in degrees to radians. So we're going to try a few here. We're going to try converting 60 degrees to radians. Now, if your radius of your circle isn't given, we are always going to assume then the radius is 1. So if I want to convert 60 degrees to radians, what I'm going to do is I'm going to plug that into the formula here, 60 degrees times pi divided by 180 degrees. So I'm going to just treat the 60 over 180, I'm going to treat that like a fraction. And I can divide, 60 goes into 180 3 times, so it'd be like 1/3. So then I'm going to keep my pi in the numerator, and I'm going to have a 3 in the denominator. And so 60 degrees is the same thing as pi over 3 radians. And we abbreviate radians as RAD. Okay, let's try converting negative 315 degrees to radians. So I would take my angle measure, negative 315 degrees, times that by pi, divide it by 180 degrees. Okay, so I'm really just reducing this fraction, negative 315 degrees over 180 degrees, and 45 can go into negative 315 7 times, so negative 7, and then it can go into 180 4 times. So we're going to have negative 7 pi over 4 radians. And that would be our final answer there. Okay, we can also convert an angle measure in radians to degrees. We would use the formula theta measured in degrees times 180 degrees divided, theta measured in radians, right? Times 180 degrees divided by pi. So let's try converting a couple angle measures expressed in radians. We'll convert them to degrees. So let's start with 5 pi over 6 radians. What we're going to do is we're going to take that 5 pi over 6 and we're going to multiply it by 180 and we're going to divide it by pi. So it would be the same thing as saying 5 pi over 6 times the fraction 180 over pi. So our pi's are going to cancel out here. I'm going to multiply 5 times 180, which is 900. Now I could certainly divide, I know 6 goes into 180, I could reduce it then, but let's just continue what we're doing here. So I would have a 6 on the bottom, and then when I divide those, I would get 150 degrees. So 5 pi over 6 radians is the same thing as 150 degrees. Okay, so let's try 7 pi over 12 radians. So I'm going to take my angle measure in radians, 7 pi over 12, and I'm going to multiply it by 180 degrees, and I'm going to divide it by pi. So again, my pi's are going to cancel out, and then you can multiply 7 times 180. You can multiply across there to give you, I think that's 1,260, and then divide that by 12. So then you're going to get 105 degrees. So 7 pi over 12 radians is the same thing as 105 degrees. Okay? So let's have you practice a couple. What I want you to do is I want you to convert 65 degrees into radians, and I want you to convert negative pi over 20 radians to degrees, and then I want you to graph each angle in standard position, so on the XY axis. So go ahead and pause the video and try problems A and B, and when you're done you can press play and we'll go over the answers. Okay, so now that you have your problems done, let's check over your work. So converting 65 degrees to radians, we want to take our formula, theta degrees times pi over 180 degrees, and we're simply going to just reduce our fraction here, 65 over 180, which gives you 13 over 36. So the equivalent angle is going to be 13 pi over 36 radians for your final answer there. And when you graph that in standard position, that's going to put you in quadrant number 1. Okay? Now, turning negative pi over 20 radians to degrees, I want to use my formula theta measured in radians times 180 degrees divided by pi. My pi's are going to cancel out, as you can see, and I'm going to have basically negative 180 degrees divided by 20 gives me negative 9 degrees. Okay, it's a pretty small angle. Because it's negative, we're going to be going clockwise around the origin, and that's going to put us in quadrant number 4. And so negative pi over 20 is the same thing as negative 9 degrees. Okay? So the next thing we're going to talk about is arc length. And arc length is the actual length of a portion of a circle's circumference that's intercepted by that angle theta. So you can think about like the arc length is like the crust on a piece of pizza or a piece of pie. How much do you get? It's a linear distance. And depending on if theta is measured in radians or if it's measured in degrees, we have two different formulas. So if theta is measured in radians, we can just take that radian measure, theta, and multiply it by the radius, r, to give us our arc length, s. If we are in degrees and we want to find arc length, what we're going to do is we're going to take our angle in degrees, multiply it by pi, multiply it by the radius of the circle, and then divide it by 180 degrees. So let's try a couple. So let's say I have a circle whose radius is 5 feet, and we have an angle of 100 degrees, and we want to find the arc length here. So we'll say this is S. We want to find the arc length. So since I'm in degrees, I want to use the formula for arc length in terms of degrees of the angle. So that's going to be theta times pi times radius, theta degrees, divided by 180 degrees. So I'm going to just simply plug everything in. 100 degrees times pi times 5 divided by 180 degrees. Okay, so we're going to just simplify. I'd grab my calculator right now. I'd multiply 100 times pi times 5 and then divide it by 180 degrees. And just as a side note here, if you have a pi button on your calculator, I would make sure to use that pi button versus using 3.14 as a substitute, because the answers can vary just slightly there. So you should get a final answer of 8.73 feet as your arc length. Okay, let's try B. This time we have a circle with a radius of 2 inches, and we have an angle of 5 pi over 4 radians. I know it's in radians because I don't see a degree symbol next to the angle, so that's implying that we're in radians here. So since we're in radians, we are going to use the formula for arc length in radians. So what we're going to do is we're going to take the radius of the circle, 2, and we're going to multiply it by our angle measure in radians, 5 pi over 4. So that gives us 10 pi over 4, and I would just grab my calculator at this point and do 10 times pi and then divide it by 4. So that's going to give you 7.85 inches as your arc length, and I always like to round to about the nearest hundredths, so 2 decimal places. Okay, so I want you to try one. We have a circle here with a radius of 3 meters and an angle of 145 degrees. So I want you to pick the right formula, and I want you to find arc length. And don't forget your units. When you're done with the problem, go ahead and stop the video, and when you're done, press play and we'll go over it. We'll go over the answer. Okay, so let's see. Since we're in degrees, we are going to be using the formula for arc length, which is theta degrees times pi times r divided by 180 degrees. Okay, so I'm going to input what I know. I know theta is 145 degrees times pi times radius, which is 3, and then divide that by 180 degrees. Okay, so I just simplified the top. You want to multiply everything together, 145 times pi times 3, and then divide that by 180, and you should get a final answer of 7.59 meters. Okay, so the last thing we need to talk about here is the area of a sector. The area of a sector is similar to arc length, but instead of talking about the crust on a piece of pizza or a piece of pie, we're talking about the whole area of that slice of pizza or that slice of pie. Okay, so since it's a portion of the circle's area, we're going to modify that formula for area of a circle, which is pi r squared. So if we're in radians for our angle measure, we're going to use the formula theta times r squared divided by 2. That's if we're in radians. If we're in degrees, we're going to use the formula theta degrees times pi times r squared divided by 360. So let's try a couple of these. Let's see, we have a circle that has a radius of 14 feet, and the angle measure looks like it's a 90-degree angle there. You see that perpendicular symbol. So if I wanted to find the area, I'm going to use my formula theta degrees times pi times r squared divided by 360 degrees, plugging everything in. 90 degrees times pi times 14 squared, and then divide that by 360 degrees. Now with the order of operations, you need to do the 14 squared first, and then you want to multiply by the pi and the 90, and then go ahead and divide that by 360. Okay, so you're going to get a final answer of 153.94, and our units are going to be feet squared since we're talking about area. Okay, let's try example B here. We have a circle, has a radius of 3 centimeters, and the angle measure is 5 pi over 3 radians. Because I don't see any degree symbol there, that's assuming we are in radians. So then my formula is going to be theta r squared divided by 2. So I'm going to plug everything in. 5 pi over 3 times radius squared divided by 2. Okay? So I would do the 3 squared first, and that's going to give me 9. And then 9 times 5 is going to be 45 pi over 3, and then I want to divide that by 2. And that's the same thing as saying 45 pi over 3 times 1/2, or 45 pi divided by 6. When I plug that into my calculator, I'm going to get a final answer of 23.56, and my units are going to be centimeters squared since we're talking about area. Okay, so I would like you to try to find the area of a sector with a radius of 18 centimeters and an angle measure of 13 pi over 18 radians. Go ahead and pause the video, try the problem, and when you're ready to check your answer, resume playing. Okay, so since we're in radians, you should be using the formula for area of a sector given that you have an angle measure in radians, which is theta times r squared divided by 2. So plug in what you know. So 13 pi over 18 times 18 squared divided by 2. And I kind of did some simplifying there and canceled out one of the 18s, and I came up with 13 pi times 18 divided by 2. And then I grabbed my calculator using my pi button. I multiplied across the top and then divided my answer by 2, and I got 367.57 centimeters squared. Okay, the next video is going to talk about special angles and the unit circle. So thanks for watching. Have a great day.